These are actual examples of where we've had to deal with a problem and how we approached it. So this one was, this output here is the output of SP who is active that I mentioned. So this is, you run it, and takes you a snapshot of when you've run it, and it gives you a bunch of statistics. I have had to white out a lot of them here. But basically, this first one is total duration of a running query. The second one is your SPID, your session ID, and it gives you your T-SQL. It gives you your username, and then it gives you your logs. Your weights. So we ignore this top row because this is just the diagnostics that's always running. But we had a problem here where the customer was saying we seem to have an outage, like the website isn't responding. So we come on, instantly run SQL is active. We look at this whole slew of lock weights here and go, these all want, the IX means intent exclusive. So these are all looking for modification locks that are exclusive. So these are actually modifying data. When we look at the T-SQL, which isn't here because it's user data, we could see they were all updates. Update a table where value equals parameter. So they were simple, but they required an exclusive lock. Another thing we get here is you get this blocking session ID, so you can tell which session is blocking when it comes to lock weights. You can see it's mostly 686 here, which is here. So we looked at this, and the lead blocker is this one, which has async network IO weights, which means that it's finished what it's doing. It just can't push its data back to whatever application is trying to receive the data. So in this scenario, I reached out to the customer. This is happening. This process is waiting on pushing data. Turns out one of the applications actually crashed and was basically not accepting the data back. So that explains why we can push the data. So at that point, we killed process 686 and the blocking cleared instantly. All of these queries are very small queries. You can see they've used like 1 tick of CPU, if that. But they couldn't do anything because of the lock on the table. And it's worth noting that had been happening for 3 hours. 2 hours 55 here when I captured this screenshot. So yeah, for instant troubleshooting, it's great for this sort of stuff. Who is active? Load of locks. We can see the blocking here, and we can see async network IO. So there's a problem with an application, probably. Completely separate issues, completely separate customer. Again, 2.5 hours we are at this point. We come in here, we run SP who is active. We can see a load of locks into exclusive. We can see the process that's blocking them, 563. Come across here. This has got a shared lock on a data page. It does show you database name afterwards, but again, redacted. But we can also see that this query has done 7 million ticks of CPU and 3.7 billion page reads, which means it's reading a lot of data. Now, just from experience on this client site, they do sometimes have these large queries, these large reports that take this long. But in this scenario, this is a bit of a runaway. And this allowed us to run who is active, look at the locks, look at the blocks, this query, and it's only 1 millisecond when this was captured, but it was waiting for data pages, which means that it's struggling to read data, which is probably because it's reading a ton of data, and the physical reads are quite high. And just the clarification between these, reads is total data pages read, but that includes data read from memory. They're classed as logical reads, whereas physical reads is we haven't got this data in memory. We need to read it off the physical disk. Physical reads are always terrible performance because disks are slow compared to RAM. So this was our quick summary here was come here, locking, page latch, bunch of reads. Speak to the customer. Are we waiting for it to finish? Like, how important is this query? Some more information that who is active gives you off to the right-hand side. It wouldn't fit on this slide, but it gives you like the host that's running it, the application name, when it was connected, things like that. It gives you a ton of information. But we can instantly see it's locking, how long we've been locking for in milliseconds, and what our lead query is. Okay. This might be the last one. I can't remember. So this one was another problem. Customer came on, things are unresponsive, we can't run queries. Now, I ran who's active and saw resource semaphore wait and went, okay. So going back to the poison weights chart, poison weights slide, we know that that's a bad weight if we see resource semaphore. And we know that resource semaphore is memory pressure. It means that these queries here, whatever they are, this one's been running for 1 hour and 16 minutes, and it has resource semaphore weights. I bet if we convert that many milliseconds into minutes, it's probably similar to 1 hour 16. I haven't done the calculation. But please correct me if it's far off. But I would imagine it just can't get the memory to do what it needs to do. But what we can see is we've got 4 queries here which have no weights. So these ones are all running. We can see the top query's been running for 8 hours. These queries, this is the server where these are SSRS reports that run. When 1 or 2 of them run, it's manageable. From memory, this server has 450 gig of RAM. The query grant for these queries is about 150 gig of RAM. So 2 of them running is okay. 3 of them is putting pressure on memory because 3 queries are running and using no, it's slightly below. It's 450 gig total, and I think it's 140 each. So it's like it's at 420 used by 3 instances. And you've got 30 gig to play with, so it's putting a lot of memory pressure on. But it will allow other queries to execute, so you shouldn't see resource semaphore. But when 4 of them are running, that's it. You're out of time. And we could see that this one had been running for 8 hours, so there was some logic stuck somewhere. So we can come here, we can instantly see memory pressure, 4 queries that are running. Off to the right is how much memory they're using, although it's not always reliable in my experience from the DMVs. Alternatively, B allocations is usually a better indicator of how much memory it's using. And we can see our problem queries, the SPIDs. We did end up killing session 337, which gave just enough resources up that these other processes could execute. Like the page life expectancy, which is an indicator of memory pressure, was dropped to the floor. It was like under 100 seconds of page life expectancy. But it got it working. It allowed queries to process, and then we waited for the remaining 3 reports to finish. So again, these 3 issues were P1 issues. And the first thing is to run who is active, which shows us the wait stats, which tells us where the problem is. It's a way of reacting and getting a quick answer to your question is what's wrong. Because SQL servers aren't great at communicating that to you sometimes. Okay. Oh, there is another one. So this one here, completely separate issue. Run who is active. We can see the wait info is page IO latch shared. So that means that we're having troubles getting hold of data pages. Sorry, there is an exclusive down here. I take that back. There's an exclusive. So that's an update query. But anyway, queries are having problems getting hold of pages, data pages. What this usually is that you've got one query which is running away, doing a ton of page reads. It's either saturating your network or maxing out the throughput on your disks, depending on your disk performance. So for this one, we can see this top query here is 8 hours, 8.5 hours. It's used 56 million CPU ticks. If we were to go over further, it would show an enormous amount of page reads. So again, a problematic page query. Problematic query, sorry. We could see Our wait stats are page IO latch shared. So these are all read queries. Just try to get hold of data pages, and they can't. So that wait stat tells us disk or network caused by an extremely large query reading a ton of data. So again, the actual fix is in your hands, whether you wait for this process to finish, whether you kill it, whether you move data files onto other disks, which isn't an immediate fix, but you can spread your workload across multiple disks. You can, if you're in something like AWS and you've got GB3 disks, then you can just up the performance. You can give them more throughput, more IOPS, things like that. So the fixes are within your hands. But what the wait stats will do is tell you the problem. If you come here, and if you don't know what page IO latch SH is off the top of your head, you type that in to Google. The top result will be SQLskills.com. You'll click on it. It'll tell you what it is, why it is, and then you can decide on how to fix it from there. So again, lots of information you can get from wait stats that will help you diagnose a server. I love waits. I don't, but I love the information you can get from wait stats. They'll tell you what's wrong 95% of the time if it's a performance issue.